Kumar Surde, Assistant Professor, Department of Mechanical Engineering. Today, we are going to solve the numerical on relative velocity and acceleration in a mechanism. Learning outcome: at the end of the session, student will be able to draw acceleration diagram for a mechanism by relative velocity method. In the previous section, we have discussed the relative velocity method and we have drawn the velocity diagram, and from the velocity diagram we have determined the velocity of the slider and angular velocity of link BD. We will continue the same problem for acceleration diagram. So, before we start the acceleration diagram, the calculations which we have done from the velocity diagram, that is link AO, the velocity is 3.4 meter, for AB it is 0.9 meters per second, for BC it is 2.8, DB 2.4 and velocity of slider is 2.05. Now, before we start the acceleration diagram, we have to calculate the accelerations of various points with respect to some other point. So, radial acceleration of any link, suppose link AO, the radial acceleration of AO is given by V square AO divided by link length AO. So, relative velocity of A with respect to O, it is 3.4 meter per second, its square divided by link length AO is 0.180, and therefore the radial acceleration of AO is 63.9 meters per second square. Similarly, the link AO has angular acceleration of 50 radians per second square. Therefore, link AO will have its tangential acceleration, that is given by alpha AO into link length AO. So, alpha is 50, link length AO is 0.18 meter, and therefore, the tangential acceleration is 9 meter per second square. So, the radial acceleration is 63.9 and tangential acceleration is 9 meter per second square. So, when any particle moves along a circular path, it has two components of its acceleration, one is radial, other is tangential, and hence according to that we have calculated the radial and tangential component of link AO. Similarly, we can calculate the radial acceleration of link BA in the same way, and that value becomes 2.25. For link BC it is 32.5 and for link DB it is 10.08, and its tangential acceleration for the various links such as AB, BC and DB at this moment it is unknown. So, with this data we can start to draw the acceleration diagram. Radial acceleration always act parallel to the link towards the center. Tangential acceleration always act perpendicular to its radial acceleration or perpendicular to the link. So, with this we will start to draw the acceleration diagram for the given problem. So, before we start the acceleration diagram, take certain suitable scale. 1 centimeter is equal to 7 meter per second square, depending upon the magnitude of acceleration of AO. Okay. Now, mark point O, O dash and C dash as a fixed point in space. So, radial acceleration of A with respect to O, whose magnitude is given by 63.9, and the radial acceleration of A with respect to O, it will act parallel to link AO and towards O. Hence, from point O dash draw a vector parallel to OA. So, from point O dash, draw a vector parallel to link AO. So, this vector O dash x dash, it represents the radial acceleration of AO. Its tangential acceleration is given by 9 meters per second square. So, tangential acceleration always act perpendicular to link AO or perpendicular to this radial. So, from point x dash, draw a vector perpendicular to link AO or perpendicular to the radial. So, this vector x dash a dash, this will represent the tangential acceleration of AO, and if you join O dash a dash, then this will represent the total acceleration of A. Total acceleration of A. Now, next, link acceleration of B with respect to A. It has two components. One is radial, another is tangential. Radial acceleration of BA is 2.25 meter per second square. Radial acceleration of BA acts parallel to link AB toward point A dash. Draw a vector A dash y dash. This vector A dash y dash represents the radial acceleration of BA. Now, its tangential acceleration is unknown, but we can find out the direction of tangential acceleration, which is perpendicular to link BA. Hence, from point y dash, draw a vector perpendicular to link AB. Now, at this moment, we don't know the magnitude, hence we have to just draw the vector. Okay. Now, acceleration of B with respect to point C. So, radial acceleration of BC, it is 32.5 meters per second square. So, we know the magnitude. Direction of radial component of B with respect to C, it will be parallel to BC and acts towards point C. Hence, from point C dash in the acceleration diagram, draw a vector C dash Z dash parallel to BC towards center point C. So, from point C dash, draw a vector parallel to BC, link BC. So, this vector C dash Z dash represents the radial acceleration of B with respect to C. Its tangential acceleration is unknown, but the direction of tangential acceleration of B with respect to C is perpendicular to BC or perpendicular to this radial acceleration. Hence, from point Z dash perpendicular to the its radial acceleration. So, we will just draw it as a dotted line, okay, and this your tangential acceleration, that tangential acceleration of BA, it will intersect somewhere and you will get point B dash, okay. So, y dash B dash represents the tangential acceleration of BA and Z dash B dash represents the tangential component of B with respect to C. Now, acceleration of D with respect to B. Radial acceleration of dB we have calculated 10.8 meters per second square, and that radial acceleration will act parallel to link BD and it will act towards B. So, from point B dash here, draw a vector parallel to link BD. So, this is vector B dash S dash. This vector will represent the radial acceleration of dB, and its tangential acceleration will be perpendicular to this radial component or perpendicular to link BD. Hence, from point S dash, draw a vector perpendicular to the radial. So, this is shown by a dotted line. Now, absolute acceleration of slider D. As slider D reciprocates along the horizontal path, the absolute acceleration of slider D is obtained by drawing a vector parallel to the path of reciprocation from fixed point O dash. Hence, from fixed point O dash, draw a vector parallel to the path of reciprocation. So, this vector will cut the previous vector at point D dash. So, this will be vector O dash D dash represents the acceleration of D, vector S dash D dash represents the tangential acceleration of BD. So, this completes the acceleration diagram. Now, so acceleration of slider D that can be obtained by the acceleration diagram by measuring the vector O dash D dash. So, with the help of scale, measure the length of vector O dash D dash and calculate the acceleration of slider D. So, that acceleration of slider D is 13.3 meters per second square. Similarly, we have to calculate the angular acceleration of link BD, which is given by tangential acceleration of link BD divided by link length BD. So, this tangential acceleration of BD that can be obtained by measuring the vector S dash D dash. So, with the scale, measure vector S dash D dash, multiply by scale, you will get the tangential acceleration of that particular link BD. Put that value here, and link length of BD is given as 504.21.3 radians per second square. So, this is how we can find out the acceleration of the slider as well as the angular acceleration of link. This particular content is referred from a book of Theory of Machines by Khurmi R.